Hey everyone, we are going to take a look here at how to graph a histogram from uh, a random variable probability distribution in your calculator and how to calculate the mean and standard deviation. So if you can please turn to page 394. I just want you to know if you don't get it, I have wanted to say that ever since I became a teacher, having read Harry Potter. Anyways, on page 394 of your book is the example that we're going to use. So we're going to go back to Pete's Jeep tours, and we've got on page 394, we have his probability distribution. And so we're going to enter that into our calculator and do some histograms and do some calculations. So if you go to Stat, Edit, we're going to put our the values of our discrete random variable into L1. So for this random variable, that's 300, 450, 600, 750, and 900. And then in L2, we're going to put the probabilities. So that's 0.15 for 300, 0.25 for 450, 0.35 for 600, 0.20 for 750, and 0.05 for 900, making sure they all line up correctly. Now, this histogram part is new. We haven't done this before, so we're going to come to second stat plot up here. So second y equals, and we're going to go into this first stat plot. So we're going to press number 1, and we want to turn it on. And then we want the type to be the histogram, which is this bar graph looking one. Now in your computer, or on your calculator rather, it's going to look a little different because you guys don't have this specific version, but you're still looking for the type that has these bars. So that's what we're going to select. So notice it changes. I do want my X list to be L1, but I do want my frequency to be L2. So I want it to look at that probability as the frequency. So I'm going to come to second 2 to change that to L2. And I want to see if I can get this to, if there's an option for this to be, that's not what there we go. This way it'll look a little bit more like yours. Next, what we need to do, if we were to go to graph now, it would give us, we actually don't see anything here, right? So next thing I would start with at least is to come to zoom and come down to your zoom stat, which is number 9 here. Went one too far, way too far, sorry. So zoom stat and see if that gives us something closer. All right, so we're closer to where we want to be, but we still need to play around with this window. So we're going to come to the window. Usually we actually want our X minimum to be a little bit less than our minimum, than our smallest X value. So let's actually set that to, let's try 200 here, and let's make our X maximum be a little bit more than the 900. So we'll set it to 1000. And then we can scale this. This is scaling by 600s. Let's actually scale by 150, since those are the jumps that are being made. So we're going to scale that by 150. Then we're going to take a look at our Y minimum and our Y maximum. Now, right now, I see the immediate problem. This is scaled as 1. And we don't want it to scale by 1s. Let's set this to 0.1. And then let's see, our Y minimum is fine. Let's do our Y maximum. Let's see, our largest probability on page 394 is 0.35. So let's set this to 0.5. And let's see now if we've got a better graph here. So we'll go back to graph. And from here, we could describe the shape of this. Think about for a moment how you would describe the shape of this histogram, this distribution. Also, just so you know, they're just talking behind themselves. So I'd probably describe this as roughly symmetrical. Maybe, yeah, I would say this is probably roughly symmetrical. Obviously, it's not exactly symmetrical, but it's roughly symmetrical. With one peak at this, one peak at 600. So there's my histogram. Now, if we come back to stat and over to calculate, now we can calculate our mean and our standard deviation. So we're going to use one-var stats for that, one variable statistics. Since this is a probability distribution, we do want the list, the x values, right? The values of the random variable are the list, so that's L1. And we want the frequency list to look at the probabilities. So we need to change that again to be L2. So we'll press second, make sure we have that little up arrow, and come down to 2. And then down here to calculate. Be really careful when you are using your symbols. The calculator gives us x bar, but the symbol we use for the parameter, the mean parameter, the mean of the random variables is that mu symbol. So make sure when you're writing it down that you use the mu symbol. So we get a mean of $562.50. and a standard deviation of $163.46. So over many, many, many trips, Pete can expect to collect on average $562.50 for a randomly selected trip. The amount that Pete collects typically on any randomly selected trip typically varies from the mean of $562.50 by about $163.46.